Welcome, everyone. Today, I'm Janelle McCoy with the Mid-Atlantic Geospatial Users Group, and I'd like to welcome you to the webinar entitled Using GIS Data for 3D Mapping, Modeling, and Design with Autodesk InfraWorks 360. Thank you for being with us today. Just some short announcements before we get started. Please note that this webinar is being recorded and will be available at the MAGTUG.wordpress.com website shortly after today's live broadcast. Please visit our slightly redesigned website for more Mid-Atlantic geospatial transportation goodness coming up in 2017. We have an exciting webinar schedule starting the year off with a bang with 2 webinars in January being hosted by MAGTUG's new sponsor, Autodesk. Autodesk makes software for people who make things. If you've ever driven a high-performance car, admired a towering skyscraper, used a smartphone, or watched a great film, chances are you've experienced what millions of engineers, artists, and designers are doing with Autodesk software. As always, we ask you to participate in today's webinar by typing questions that spring to mind throughout the webinar in the chat box or the question box on the bottom right of the WebEx window. I, or our presenter and co-host, Eric Chappell, will read back your questions at the end of the webinar so that everyone has the opportunity to hear the answers and better understand this great tool. And now it is my pleasure to introduce Eric Chappell. Eric is a civil community evangelist with Autodesk, where his primary responsibility is to inform and empower the Autodesk user community that specializes in GIS, civil engineering, and infrastructure. He has worked in the civil engineering world for 25 years and is a recognized expert in his field, having published numerous books, online courses, and white papers related to the use of computer technology in civil infrastructure projects. Eric will be walking us through InfraWorks 360, an amazing product from Autodesk that allows many types of GIS data to be aggregated in an immersive geospatial environment. Using this environment as a backdrop, powerful design tools allow engineers and designers to create roads, bridges, and many other design features. Eric will show us what it can do and how it can work. It can help work in the transportation engineering and GIS worlds simultaneously. Eric, the virtual floor is yours.
Thanks, Janelle, and welcome everyone to today's webcast. I really am honored that Autodesk can now be a sponsor for MAGTUG. We've already done one event, and we are looking forward to doing many more, both virtually and in person. As Janelle mentioned, my name is Eric Chappell, Civil Community Evangelist for Autodesk, and she's kind of covered what I do quite well. So I'm actually going to do something what I consider to be a little bit unorthodox. Typically in a webcast like this, we would go through a long introduction as to who is Autodesk and who am I and what do we do and what kind of products do we sell and what kind of customers do we serve. And I thought, you know what, you folks are here to see this really amazing technology, and I'm going to start there. I'm actually going to jump into a little bit of a product demo and just get you excited right off the bat about what this thing can do, and then maybe we'll jump into a little bit more on who Autodesk is and what we can do. So let me switch over to our product, InfraWorks 360. So this is the main screen of InfraWorks 360, and what I'm going to do is open what's called the Model Builder tool. And I can start anywhere on Earth and type in a location in preparation for this presentation, which quite frankly I didn't spend tons of time preparing because with InfraWorks you really don't need to. I found that I believe the Mercer County government office is located somewhere in this area around Ewing, New Jersey, if I'm saying that properly. So I can type in any place name. I can type in Ewing, New Jersey. I can type in meteor crater. I can type in Mount Rushmore, place names, things like that. But let's go ahead and do a place that at least I know some of you on the call are familiar with. And I'm just going to zoom into an area. I can select my area by zooming in. I can select it by drawing a box, draw a shape, or I can even import a shape file to define the area that I want to build my model for. And then next I'm going to choose kind of a location where I want my model to live, and then I'll give it a name. And I'll explain in a moment what InfraWorks 360 is going to do, but I'm actually going to call this Mercer 3 because I've already got a Mercer 2 up there. So I'm going to enter all that information, select it in area, then I'm going to click Create Model. So let's talk about what I just did. I submitted a request to the Autodesk cloud, if you want to call it that, and I told it what area I wanted to model. In the future, we may see options for exactly what data we want to extract to build the model, but for now it's pretty much a data set that you pull from, and we build. What's going on in the background is in the cloud this model is being built by grabbing open source GIS data. So OpenStreetMaps, and I'm going to go ahead and notice the tile popped up here. I'm going to go ahead and click that tile and get the software started with downloading and opening that model that it just created. So we use OpenStreetMaps to grab road and building, rail, and road is transportation. So road, building, rail, and water features. We use USGS to capture terrain information, and we use Big Maps imagery to do the aerial photography. So it's all free open source stuff just to get you started in whatever area you want to study or look at designing for a given project. Now, of course, if you're outside the United States, USGS data isn't going to do you any good, but we have that covered too. Just about anywhere on Earth where you'd ever want to do a project, maybe with the exception of the North Pole and South Pole, we can go out and grab data for you to get you started. Now, I'm not sure what our mixture of personas is on the call, but I'm guessing we've got some GIS folks and we've got some engineering folks as well. If you're a GIS person, you might not find this super impressive that we're going out and grabbing open source GIS data, which is, it's freely available, so it's not the greatest accuracy, it's not the most up to date. But if you're an engineer, this is pretty awesome because I don't know if you GIS folks are aware of this, but civil engineers are very dependent on the work that you do. Every single project, just about, I would even go so far to say as every single project, starts out in its early stages with needing to have some preliminary data to establish the existing conditions of the project. I'm going to design a new road, I'm going to design a shopping center or a residential development. Before I do anything, I need to know what's there now, what's it look like now, what am I tying into, what's in the surrounding area, and you can think of that all as context. And before tools like InfraWorks 360 were available, engineers would have to go out and find GIS data wherever they could, whether they just searched for it on the internet or purchased it from their local municipalities or counties. But every project generally starts with that GIS data, and that could be a difficult process, especially for engineers who are trained and brought up to be engineers and aren't necessarily very good with GIS data and dealing with different coordinate systems coming together and knowing how to read metadata and all that stuff. It could be a real challenge to go out and grab some building information, some terrain information, some road information, and actually have it all fall in the same place in the civil engineering tools that they're using. For example, Civil 3D, which is our civil engineering design tool. That was a big job, and it was something they had to do all the time. So making it this easy, almost like the push of a button, is a really big deal for them. So all of you GIS folks on the webcast, the next time you run into one of your civil engineer friends, I want you to look at them and say, "You're welcome," because they are using the work that you do every single day, and it's really important to them, whether they admit it or not. So let's see what we've got here, and you you can kind of see what InfraWorks 360 does from a GIS standpoint. It takes kind of plain old, normally 2D GIS data, and it makes it 3D. And like I said, this is OpenStreetMap's data, so it's not super accurate, but InfraWorks 360 does a pretty amazing job at just making the environment look amazing and be also geospatially accurate. Now, some stuff that it did, it took road center lines that it found in the OpenStreetMap's data set, and it represented them as these road objects in InfraWorks 360. So instead of just being a line on a screen, this is an actual three-dimensional representation of a road. And it even has visual properties like a style. It is truly 3D. If I zoom in nice and close, you can see I've got the curb line defined, I've got stripes on it. For whatever reason, it picked this style with these weird little pylons. But one of the great things about the product is if I don't like the way it stylizes something, I can always go and find a style that I like for it, and maybe it's something like this, and I'm just dragging and dropping a style onto the road. Or maybe this is something a little simpler, just a simple two-lane road without any curbs or sidewalks or anything like that. So very quickly I can redefine the way something looks. We see we've got some rail here. And we try to go with a balance of representing what's here accurately, but also making it look good and realistic. And what that enables you to do, and I'm going to cover some of this when I talk about kind of the software and what it's intended to do, is it makes the world understandable to everybody. I have 4 kids. My youngest is 9. I can show this to her and she understands what she's looking at. There are railroad tracks, there's a little pond up here, there are trees, and there are fields, and there are buildings, and there's an airport. If you show the average person a 2D drawing or map, which is just lines on a white space or on a piece of paper, you have to explain to them what they're looking at, or you have to label it very well, or colorize it, or stylize it. You have to spend a lot of extra time to take raw GIS data and make it look like something that the average person understands. And InfraWorks 360 does that, that's what it does. It does that naturally and immediately and without any effort. And then, if there are areas that you need to tighten up or be more accurate or represent in a different way, it's very easy, as you saw, to do that with a road. Let's talk about the buildings that we have here. These were just building footprints that were grabbed from OpenStreetMaps, and the software, frankly, doesn't know what the buildings look like, so it randomly assigns facade styles to these buildings. So I may go to this building and I know what it looks like, and in fact I can, I'm not sure what it is, for some of the buildings, if the information's there, I can hover over them and find out what the building is. So far I'm not getting lucky and getting a name for the building. And I was looking at this earlier. There were some hotels around here that had names, but they're not popping up for me. But in any case, you can represent the buildings in a different way. So, let's say this white building here. Well, this happens to be a brick building. No problem. I can go to my facade styles and find a brick style that more accurately represents what that building looks like. And as you would guess, the environment's customizable. So if I wanted to create a facade style that more accurately represented that building, I could do that. Or if I wanted to send out a drone and scan that building, take a bunch of photographs of it and fly around it, and use our recap product to turn that into a 3D model, I could drop that into this space. Just literally take out this building and drop a more accurate 3D model representation, whether it's a laser scan or something created from a drone, or even something built in Revit or SketchUp or some other product. I can spend as much time as I want in certain areas, tightening them up and making them look like they really do look in the real world. I can also make adjustments to the model. You know, we make some assumptions when we're trying to take 2D GIS data and turn it into 3D. For example, these roads don't have elevation data on them. We basically drape them over the terrain data that USGS gives us. And to make things like overpasses, we have kind of hard-coded into the software a default or minimum clearance between a bridge and a road. And if there's no elevation data, it basically just sets the bridge at that minimum clearance. And it works pretty well, but sometimes you get a little bit of weirdness like we see here. But because this is an editing environment, you know, it's actually not a big deal. And this is an actual bridge object. I'm going to add a vertex here. And I'm just going to raise up the center a little bit to flatten this bridge out a bit. And for whatever reason, I got a little jump in the road here. But the key point being here is that I can make edits if the way things turned out isn't exactly perfect. All right, and that's so far just what I've done with the freely available OpenStreetMaps data. Now, I know that you guys have access to all kinds of cool other stuff, and that's where it really starts to get exciting, because I can close down the style palette, because I can supplement, I can use what Model Builder gives me as just a starting point, or I can ignore Model Builder altogether if I've already got a good strong library of GIS data. Although it is nice to use Model Builder because Model Builder helps set up your model in kind of the right coordinate system in the right place on Earth. Because I am dealing with a geospatial environment. Let me show you what I mean. If I zoom out from this model and just keep going and going, you'll notice that I am in fact in the New Jersey area. So I'm properly located on the face of the Earth. And I am working in, by default, lat-long coordinates, but at any time I can go into the properties of the model and switch to a different state, a different plane, or a different coordinate system. Like I'm going to switch to New Jersey 83 feet. Just like that, click OK. And now you'll see the coordinates reading out in the bottom left corner are New Jersey state plane in units of feet. So switching coordinate systems is fairly easy. Something else that I find pretty impressive, the fact that I'm using basically kind of sketchy GIS data that's freely available. The software did a pretty good job of modeling this pretty complex cloverleaf interchange here. There are some edits I could make to this bridge, but I've seen the software evolve over the last couple of years. And by the way, this is a very new piece of software. It's only existed for maybe a total of 5 years, but publicly available and actually a viable product maybe 3 years. So this is a very, very new product, and I've seen it evolve from this being a pretty rough-looking solution to what we're at now, which is pretty exciting. So let's talk about, I was talking about just a minute ago how Model Builder is just your starting point. What if you've got other much better GIS data to work with? And that's all possible to use to either supplement or improve what the software gives you. So what I'm going to do, I'm going to create what's called a proposal. And this is just a different version of the same model. And I'm going to call this My GIS, meaning that the master proposal is kind of the beginning, the pristine beginning, and with My GIS, I'm going to take what I get here and supplement it with my own GIS data. And to show you that, probably the best way is to go to this Data Sources command, or Data Sources panel. And you can see all the data that's been automatically added from Model Builder in this list here, buildings, and we've got some coverage areas in here. Let me see if I can find any. There are times when the software will call out certain like athletic fields or something like that it deems coverage areas, and I'm not seeing any off the bat. So we've also got ground imagery, obviously. We've got railways. You can see one running through here. We've got roads, and we've got terrain and water areas. Oh, one fun thing I didn't talk about was the fact that the software is animated. And I know that this doesn't come through in a way that even does it a little bit of justice on webcast, but there's this very cool shimmering effect on the water that just makes it look like, it's kind of a windy day and the water's a little choppy. And it seems silly and aesthetic, but it really does bring the model to life and make the people who are looking at it feel like they're there. They're really experiencing this. It's like you're flying them around in a helicopter or something of that nature. And just to have a little more fun with the animation, I'm going to go to my sun and sky settings and make it a little cloudier today and a little windier to get those clouds moving. And again, from my perspective, that looks like a windy summer day. It's so smooth and animated, but I know it's a little choppy for you coming through the webcast. So anyway, back up here to the Data Sources tab. Oh, sorry for jumping around, but things jump into my head and I get excited, so I feel like I have to tell you. Not only are we geospatially accurate with this model, but we're also accurate with the location of the sun. So I can go in here to sun and sky, and if I change the time of day, you'll see the shadows changing in the model. And I can model an exact date and time for this location. The model already knows where it is on the Earth, and all I have to do is tell it what day it is and what time it is, and it will show me what the shadows look like. So again, a way to get some more realism in the model, but we actually have sometimes some practical applications for that too. So what about other data? I've got my own data that I want to add in. If I click this little drop down here, you'll see all kinds of information that you can add in. A lot of Autodesk stuff, but also a lot of generic or other third-party stuff. You can add just about any kind of 3D model. Lots of AutoCAD, DWG, Civil 3D, IMX, Revit, if you're familiar with our main architectural design product, Revit. So if somebody has designed a building in Revit, you can drop it in. And then we get into some other stuff, City GML, DGN, if there's anyone from Bentley on the line, you're quite familiar with that format, IFC. And then we get into some even more generic formats like Land XML and just point clouds. Although I will say point clouds need to be converted to our RCP format, which you can do with a free version of Recap. So if you've just got an XYZ point cloud, you'll have to index it and convert it, but those are supported as well. SDF is our spatial data format. That's our kind of our GIS format. SHP, I know you all are very familiar with, and then we also support SQLite and SketchUp. So that's just one aspect. Now, I should have said this disclaimer at the beginning, but I need to tell all you guys, I am not a GIS person. I'm an engineer, and my depth of understanding of GIS is pretty limited. So what I'm going to show you next, I admittedly don't understand most of what I'm showing you, but I'm sure some of you will. We can also connect to data sources, and you can see some of the choices here: Oracle, SQL Server Spatial, WFS, a simple direct connection to Bing Maps if we want to use that. And then there's this interesting generic connection, and this list is pretty impressive, so long that it doesn't fit on the screen. And without really knowing what most of this stuff does, I'm hoping some of you are seeing some choices here that make you excited, and if nothing else, just to show you that we have a lot of different ways to attach to geospatial data. And even if you don't see what you'd like to, we also support scripting, which can a lot of times help you get where you need. So if I go to this screen here, you can see we have a scripting interface. This is JavaScript. And I've seen, there's a gentleman that I work closely with here at Autodesk, Wes Newman, who can do complete magic with JavaScript and some GIS data sources that, if you ever have any specific thing that you want to try to do with InfraWorks, please email me, and I'll hook you up with Wes, and we'll figure out how to get it working for you, because he loves doing that kind of stuff. The best way to incent Wes is to tell him it can't be done, because he will find a way to do it. So lots of different ways to get the data that you have access to into this product to supplement or improve what Model Builder gives you. So let me show you how easy some of that can be. And Janelle actually supplied this data to me about 45 minutes ago. And I literally extracted it. It was a zip file. Extracted the zip file. I'm going to grab the shape file and drag and drop it right in the model. Before I do that, though, this is building footprint data. So I'm just going to take out the buildings that I have now. So I'm just going to select all of them and hit the delete key and take that out. And then I'll go back to my folder here and just simply drag and drop that data. So what I can do here is I can tell it what kind of data I just brought in. Sometimes the software is smart enough to know that this is terrain data or it's raster data based on the file type. If it's a straight up shape file, it kind of doesn't know what kind of data that is unless you tell it. So I'm going to tell it it's buildings, so the software classifies it properly. And I'm going to tell it what coordinate system it's in, which I believe it's in New Jersey 83 feet. There may be some information I need to tell it with the source, like I'm assuming this is the whole county, so I don't need to bring in the whole county and then crop it, just bring in the area that I have. Sometimes GIS data has its own elevation data and you want to drape it on the surface. You can do that if you need to. And then there's all kinds of stuff you can do as far as mapping information in the drawing to information in the data source, attribute information. So what you're looking at here, these are all of the different pieces of information that InfraWorks 360 stores for buildings. And I can go in here and say, I want to match the building description to something that's coming from the building data itself. Now, I don't have a whole lot of familiarity with this data set. So I'm not really, let's do address. Okay, so I'm going to do the address of the building. And that'll fill in the description part of my buildings. And then what I'm going to do is go into the tooltip just to show you some of the capabilities you have here. This isn't just, pretty buildings spread out across the model. I'm going to go in here and add the description to my tooltips. So I'll close and refresh that, and now you can see it's populated the model with all those buildings. And what it's done is it's taken just the building footprints and extruded them. And I didn't really apply a building facade to any of these, so they're kind of plain looking. And there's just so much I could do if I had time to make this data even more interesting than it is. But what I should find is if I go in and check out a tooltip and hover over the building and edit this tooltip, I must have done something wrong here because it didn't pull out my information. So let me try that again with a single building. I'm going to bring up the description, and now when I hover over that building, it should give me the address. So this information is all coming across in InfraWorks 360, and I can run queries on it. I can theme it out and stuff like that. Let me see what else we can bring in here. You'll notice there's not a whole lot of water information in this model. I've got a couple of ponds. I don't see any streams anywhere. So let's go ahead and bring across some streams data. This I got from the New Jersey website, and I went digging around last night or the night before just looking for some cool data to drop in. I found this, and again I'm going to tell it these are actually water areas, which may seem a little weird. I'm going to give it a buffer width, so all the streams are going to be 5 feet wide. If the data itself had average width information or width of each segment, I could map that to this field so that the streams actually came in the width that they were. I do need to go into my source settings here and drape this, because if I don't, just from experience, and this happens sometimes and sometimes it doesn't, it'll actually dig the streams out down to like elevation 0, so I end up with these really deep chasms with streams running at the bottom of them. But if I tell it to drape them, it'll drape them right on the surface of the terrain. And I think that's all I need to do for these guys. So let's go ahead and close and refresh that. And now we've got some streams in the area. So just like that, we can represent pretty much any data source we can get our hands on, we can bring into this model. And I want to talk about some of the theming we can do. And actually, let's see, let's do a terrain theme first. You know, just real quick, I'm interested in what's going on with this terrain. I'm just going to create a new theme based on elevation. It's going to have 6 gradations in it. I'll click OK, and this allows us to see, you know, what's going on with elevation in the model. So just a very simple example. This is a pretty flat area, so we're not seeing a whole lot of different colors, but a really simple example of some of the theming you can do. You can also do something called a feature theme. Now, I really don't, might be limited by my own creativity, but with the data I have so far, I noticed the buildings didn't have height information attached to them, so I'm not really able to do anything based on that. But just to give you an example, I can create a feature theme, and I can base it on these different object types. And if I had more object types in my model, I would see a longer list here. This is really all I have here that I can theme. But I can go in here and based on any property that's attached to those buildings, the one I typically do is height, where I say, show me all the buildings that are over 20 feet tall, and it will go through and assign a certain style to them, or actually a certain color in this case. There's 2 different things. There's a theme which adds gradation to the objects that I'm analyzing, breaks them out into however number of rules I want, 2, 5, 6, or whatever, and I can say, show me all the tall buildings in blue and all the short buildings in red, or show me any buildings that are higher than a certain property value in this color, and so on and so forth. Something you guys are, I'm sure, quite familiar with. But I just wanted to show you that these are possible to do in the software. Another thing I can do is something called a style rule. And these are even more interesting because, and I'm actually going to demonstrate this with the buildings. I have an idea. I'm going to add a style rule for the buildings just called facades. And what I can do is create an expression. I'll go ahead and edit that style rule. And typically you do assign an expression to it. So if I hit edit here, I can go into the buildings and say anything with a roof height greater than, I can just double click and build my expression, roof height greater than 20. I want it to be a certain style. So let's try that out actually. I'm going to say anything with a roof height greater than 20. That's my expression. And then what I do is I say I want that to be a certain style. So I'll click add. I pick my building facade style. And what's interesting about this is if I want to randomize this a bit, I can pick multiple styles. So let's do that one. And let's do one from the metal and glass section. And let's do another one from, I don't know, marble and stone. And what it'll do is it'll randomly apply those facade styles to anything that matches the expression. And I can even weight them by changing the probability. So if I want most of the buildings to be brick, maybe I give this a 4 and the rest a 1. Just an example of what you can do. So I'm going to OK that and click Run Rules. Now, I don't think any of my buildings are above 20 feet. So let me edit that just to have some fun here. Because all of my buildings right now are the same height. I'm going to say anything over 1 foot, assign a different facade. So now when I zoom into my buildings, I've got a randomization of facades, but if they were actually different heights, if that was specified in the source data, then I could have all my tall buildings brick and all my mid-sized buildings marble and glass and all my, I don't know, smaller buildings something else. So that's some of the things we can do, the very basic accounting of some of the things we can do with the GIS data. So let me jump over now to my PowerPoint and talk a little bit about where did all this come from and what is Autodesk about. And then if we have a little time at the end, I'm going to jump back in and show you some other stuff. So Janelle actually covered this nicely with an introduction to Autodesk and what we're about. We're about making stuff. And our new tagline, this came out very recently. In fact, I'm not even sure I'm supposed to be using this tagline, so you guys didn't hear this from me. But I love this tagline because this is what I've been telling people. I've been working for Autodesk for 3 years, And people say, who do you work for? I tell them Autodesk. Really, what do they do? Well, if anybody who makes anything, we make software to assist them. It's usually what I tell them. And that could be a machine part, a map, a building, or a movie. We also have a massive entertainment section of our company. In fact, just about any movie that you go and see that has special effects, digital special effects, which these days is just about any movie, you can bet that it was created with our software. In fact, I'm going to bet every single one of you on this that's attending this webcast has today interacted with something that was made using or designed using Autodesk software, whether it was your phone or a part in your car or an appliance in your house, the road that you drove on, any of that. It's something you interacted with, probably more than one thing, was made with Autodesk software. And Janelle actually covered this this kind of expanded accounting of what that means. You know, we make software for people who make things, and that can be just about anything you can imagine. These days, we're even making, you know, prosthetics for people with who've lost limbs and just all kinds of amazing things. How big are we? We've got millions of users. You can see the numbers there as far as professional users and consumers and students. So literally millions of users. We've got a lot of different products, as I mentioned. Our size financially, $2.5 billion in revenue in FY16. We have 2.5 million software subscriptions and almost 9,000 employees worldwide. It really is an amazing place to be a part of. Out of that long list of products, and I was trying to find an image that had all of our product logos in one place, and I couldn't find it. I know it exists somewhere, but it's staggering. It's hundreds of products. These are the ones that you guys would probably care about. Map3D is our geospatial authoring product. This is the nitty-gritty, you know, lines, arcs, and circles, and attribute data. And not only can we author data, but we can consume data from other vendors as well, like, you know, Esri and Bentley and those folks. And you know, we're talking the vector and the attribute stuff here. And then if you want to take that data and serve it up to the public or to a wider audience online, or even within the firewall, we've got Infrastructure Map Server, which does that. AutoCAD Civil 3D is our civil engineering design product. InfraWorks 360 is the product I just showed you a moment ago, and we're going to get into what its capabilities are a little deeper. And then we've also got Recap, which is our tool that's used for processing point cloud data and also photograph data. The ability to use photographs to represent things in the field is exploded with the drone industry especially. We can now, you know, fly a drone around a building or around a mountainside or around a busy intersection and just take pictures, take lots of pictures of that, and we can, sorry about that, and we can turn those photographs into a 3D model that's accurate within, I think we're getting into the sub-centimeter realm now. If you've got good equipment and you know what you're doing, you can capture a model of a building or a mountainside with a drone and a good camera. And in fact, if you go on YouTube or whatever and look around, you'll find a really cool video that we did of Red Rocks Amphitheater using Recap software and a drone and a camera, where we modeled something that couldn't have been easily modeled any other way. It's not like you can climb around and survey that thing. You know, it's just a really interesting new industry that's developing. But Recap is the tool that enables you to take that data and turn it into something. I don't know if anybody picked up on how many slides I had in my presentation today. I think it was like 75 or something, and if you saw that, you probably got really scared. And the reason there's so many is because of all these project examples that I'm going to just scroll through very quickly to give you an example of the types of projects that Autodesk customers work on. A lot of these are InfraWorks 360 images, which fell into place for today's presentation. But you know, the images may have been generated in InfraWorks 360, but I can bet you that these products used a combination of that tool and Map3D and Civil 3D and Recap. In this example here, we can see a point cloud in the inset right in the bottom left corner. So I guarantee a recap was used on that project. And that's one of the great things about Autodesk. I'm going to use kind of a sports analogy here because I'm excited about NFL football right now. I'm a Steelers fan, and they're in the playoffs. And now, one thing we have at Autodesk is a lot of depth. We have a product for just about anything. So I can say probably better than any other company out there. So you may be using InfraWorks 360 to do some of the things that you just saw, and then you hit a point where, man, it would really be nice if I have a building in this project that I really need to represent accurately and with a lot of detail. I wish I had a tool to do that. Well, we have that. We have Revit. And well, now that I have my building in the model, I'd really like to be able to visualize that in a very realistic environment. I want to be able to control the light sources and the shadows and make it look like so real that you can't tell that it's not. Well, we have a product for that. It's called 3ds Max. And you know what? I want to do something really cool for my client. I want to set it up so that they can make that, I want them to experience that project like a game. I want to drop a car into that model and have them drive around like they're playing Xbox at home. Well, guess what? We have a tool that does that too. It's called Stingray. And I could go on and on and on with just about any example you could throw at me of a product that does what you would need it to do for your project. And what's great about all of those things having the Autodesk logo on them is interoperability. So if you're doing a project that involves buildings and roads and terrain and visualization, and there's point cloud data and GIS data, we've got products for all of that, and they all talk to each other very nicely because they are Autodesk products. So that depth is something we're really proud of and we really talk about a lot. So again, just flipping through some of the different project types. And I actually reversed my order of operations for this presentation at the last minute. So you're going to see a slide further on that says software demonstration, and I've already done that. So let's get into an overview of the product. What does InfraWorks 360 do? You only saw a small piece of it. The overall idea is it's a visual 3D design and communication platform. So it's really mostly about design. As you can see, it does some amazing things with consuming GIS data, but that's really about building that context, that first bullet point in the list here. And I mentioned at the beginning of the webcast how important the work that you GIS folks do is to civil engineers in getting their projects started off the ground, because in the early part of the project, in today's world, everyone wants everything yesterday. So you can't wait 2 or 3 or 6 weeks for the survey to come back to start designing and coming up with ideas for what you're going to do for a project. Pretty much as soon as you, should have shut that off, sorry. As soon as you start a project, as soon as you get the notice to proceed, people want to see stuff. So you have to have that context, you have to have that background to build on, and that's what InfraWorks 360 does so well with the GIS data that many of you folks on this call are providing. It allows you then, once you've got that context, it allows you to create and explore and evaluate designs very quickly. And it allows you to do that in an environment that you saw, which is it's fun to look at, but more importantly, it's easily understood. Anyone can look at that environment and know what they're looking at. They don't have to have any experience with mapping or civil engineering or any of that. A building looks like a building, and a road looks like a road, and there are sun and shadows, and the water shimmers and moves. It looks real, and there's no gap to overcome with explaining to somebody what they're looking at. I just had a customer share an example with me where their town, whatever the public entity was, they wanted to improve an intersection, I think put an overpass in. And there was a business owner there on the corner who completely opposed it because he believed that this was going to be bad for business. And the folks, no matter what they did, they just couldn't convince him, and they were bringing in 2D drawings that showed the bridge crossing over and the two roads intersecting and where his property line was and where his building was, and a rectangle representing his sign. And this guy's a business owner. He probably had no training or background whatsoever in mapping or civil engineering, and he had no idea what he was looking at. And no matter how hard they tried to explain it to him, they just couldn't. And then they threw it all into an InfraWorks 360 model, which took, as you can see, very little time. And they were able to show him, here's what it's going to look like. We can actually drive a car over the bridge, and we can look over and see your business, and it's really visible. And by the way, you can have all this extra traffic going past your sign. And what I was told by the customer is that their client, or this business owner, the property the amount of money that he wanted for the property went from $10 million down to $250,000. Once he saw the value in this intersection improvement to his business, he was willing to let it go for a much lower price, whereas prior to that he wanted more than was even going to be possible. So the ability for folks to see, to experience this immersive environment is really, really powerful. So it's, you got the environment, you're designing, you're doing it very quickly, you're doing it in a very visual environment. It's just a very effective way to design and show people things. I've already showed you Model Builder, so I'm going to skip right past this, this slide. You're going to see some video here of creating designs very quickly. We can crank out roads very quickly. Not only that, we can draw sites. We can draw a graded area, put a parking lot on it, put a building on it. And the tools are made and designed to be quick and simple and easy to use. We're not asking you every single question about, for this parking lot, for example, how many parking stalls do you want? How far apart do they need to be? And how many accessible stalls do you need? That's all going to come later. We understand that at this time in the project, you just want to show that there's a parking lot here and that it can actually fit. You can grade side slopes on it and it will still fit on the property, and you want to see a building on it. And when I do that, how much space is left for parking? Those are the kind of things we're trying to establish at this point in the project. And then you can get a little deeper with your designs. The software is actually a really powerful engineering design tool. When you design a road, it's not just a pretty picture of a road. If we've got any road engineers on the call, the roads we design have horizontal and vertical curves. The curves are parabolic. They're based on AASHTO design standards. It just does it so quickly and beautifully that it's hard to imagine that this is engineered design. The bridge that's being created in the video right now, the girders are actually sized for the spans that they're going across, and the numbers of them, and the pier caps, the piling even underneath the bridges is designed all based on engineering principles. Now, we make lots of assumptions, but they're usually pretty good assumptions. And if you want to go in and tweak some things and maybe change the style of something, or add a turning lane at an intersection, or turn an intersection into a roundabout, once the design's created, you have lots and lots of power and capability to go in and make changes and tweak it. But we make the creation part very quick and easy. The editing is actually pretty easy too. I talked about the visual environment and how you can dress things up with, with people in cars and all kinds of, any 3D model you can find anywhere on the web, or something you've created yourself, you can drop it in your InfraWorks model. We can analyze what we've designed, from simple things to just measuring how far it is from one point to another. There I'm measuring from where I'm standing to a building. Here I'm measuring the cut and fill associated with this site grading project. You can measure cut and fill for a road design as well. You can even optimize cut and fill in a road design where it'll balance that out for you. And for you engineers out there, we do have profile view for roads. Engineers love to look at roads in profile view. It's the perfect intersection of engineering design tools and visual capabilities, and being able to aggregate lots of GIS data in one place. Here we're checking the clearance beneath the bridge to make sure something can pass under it. Maybe it's a flood, or we can dig right down even to the structural dimensions of bridge components. We can explore multiple alternatives. Because the tools are so quick and easy to use, this video, by the way, I haven't edited at all. It's not sped up. I haven't cut parts out. We can actually sit down with a client and, in this example, say, okay, I want to put an intersection here. Well, what if we did a roundabout? Let's see what that looks like. And okay, what if instead of a roundabout, we just did an overpass? We did a bridge at this intersection. Okay, let's try that out. You can see how quick that is. I'm going to turn the roundabout back to an intersection and just simply elevate the road one above the other, or actually dropping one road down, and the crossing road kind of immediately becomes an overpass, and now I just have to add a bridge to it. And adding a bridge is as simple as launching a command, picking 2 points, and I've got a real bridge, for lack of a better term. You know, it's got piers and piling and foundations and girders that are based on AASHTO standards, and you know, this thing, you could actually build it. So just like that, and by the way, each time I did this, I stored it as a proposal, so now I can go back to the customer or the client and say, okay, there's your bridge, there's your intersection, there's your roundabout, and I just did that live in front of that client. And let's see, that was 1 minute and 20 seconds. I don't know that there's another tool out there where I can show them an intersection, bridge, and roundabout in 1 minute and 20 seconds in a way that they completely understand without any explanation or labeling or pointing and talking and saying, you know, well, this is what this line right here, this dashed line, that's not what you think it is. That sort of exchange. We've got great sharing and collaboration tools, which I wish I had more time to tell you about them in detail. But you can publish your models to the cloud, invite other people to work on them with you, or just simply look at them and provide review comments. And all of the communication happens kind of within the product interface, so you don't have to send an email. You can actually communicate within the product. And then another thing that we are really proud of is that you can take this InfraWorks 360 model and very quickly, because of that interoperability I was talking about earlier, you can move this very quickly into Civil 3D and move on to detailed design, where you're going to do your plan profile sheets, cut your sections, you know, do the real intricate detailed design around, you know, where your accessible ramps are and things like that. And frankly, InfraWorks 360 doesn't have those super detailed tools because it's not for that way far down in the project where you're really crossing your T's and dotting your I's. It's for cranking out, you know, 5 miles of road in about 5 seconds. And just to give you some contrast, in Civil 3D, when you design a road, it's pretty much a 3-stage process. You draw an alignment, which is a 2D representation of the center line. You draw a profile, which is a representation of the changes in elevation as you drive down the road. And then you create what's called an assembly or a template or a typical cross-section, and you attach that to that alignment profile combination. Those 3 things come together and make, it's kind of a 4th step, you make a corridor out of that. Now, that's a fantastic way to design roads when you're doing them extremely detailed and you're addressing everything you need to address. It's actually critical. It's essential. That's how our customers get their road designs done. But if you're early in the project and you want to just see, can I make a road from here to here and will it work? You can do that in InfraWorks 360 by launching a command and picking 4 points. So what's a 4-step process in Civil 3D that may take you, I don't know, 15, 20 minutes depending on the complexity of the road, will take you 15 or 20 seconds in InfraWorks 360 because it does all of that at once. The alignment profile, the assembly, it's all done in one motion, and it all comes together at one time. Some other cool stuff we can do. Here we've got an InfraWorks 360 model with a point cloud in it. You can see the crisscross lines in the model, which represent the current TIN, the surface model that was created based on Model Builder. And we're going to go through some steps here and actually use this point cloud to generate the surface model. And it's going to strip out the trees. It's going to figure out where the trees are and take them out, where the houses are and take them out. Actually not take them out, just ignore them. And then I'm going to get a much more accurate surface model based on, you know, a series of laser scans that I did out in the field. So once I've chosen all my options here, I'm going to click Start Processing, and it happens pretty quickly. Now on this, when I actually do this presentation for when I have tons of time, I talk through a little bit more of what those specific options do. But it's doing some processing now, and you'll see that the terrain model becomes a lot more accurate. Not just the tighter spacing of the grid points, but if you look in this area, you can see a very well-defined driveway here and here. It just is a much more accurate representation of the terrain. And the more accurate your point cloud is, the more accurate your terrain model is going to be in that case. We can also do flood simulation, which is really cool. This is something we added recently. We partnered with a company named Hydronia, and they've got a product called Riverflow 2D, and we basically plug their product into ours, and you can define an area. This happens to be Johnstown, Pennsylvania. If any of you are familiar with the Flood City, it's actually the area I grew up in. So when I did a flood simulation, I had to do Johnstown. And you just basically outline your area, tell it where water's coming in, tell it where water's going out, tell it what your design flow is, and it will calculate the rise and flow of water in that space based on the terrain and some other factors. And you can actually animate that, watch the water rise and fall, and of course get into a very detailed analysis about how that flood event is going to impact the area that you're studying. So a very powerful way to analyze maybe not just what's here now, but what if I changed something? What if I added a bridge or took something away? Would that cause a flooding effect? It's something you can model and analyze in a couple of minutes. It's really easy to do. So easy and that it's hard to believe it's even possible.
Well, Eric, that
Yes.
is about all the time we have.
Okay.
Do you have a final wrap-up here, or anybody who wants to ask questions, please put them in so we can get to them?
Yeah, well, one thing I definitely want to make sure everyone sees is this page right here. If you want to try out the product and try what you just saw, please go and download the free trial. It's 30 days for free. You can get it at autodesk.com/InfraWorks. And you get for the 30-day trial, you get full functionality. So it's no obligation. Just go ahead and try it out and have some fun with it. It really is amazing. Do a model of your hometown or some place that's near and dear to you, and then go in and change it. Do a lake that you love, and then build a big old bridge over it or something like that. Whatever the case may be. I also want to encourage everyone to, if you have any questions about the product, or if you install that trial and you are trying to get a certain data set to work with it and it's not happening, please reach out to me. I really want to see you try out the product and be successful with it. I think you're going to be really excited with the things you can do with it. So reach out to me, and if I can't help you, I will find someone who will. Out of those 8,500 plus employees that we have, I'm sure we can find someone that will help you out. I want to thank MAGTUG for letting me do this presentation and for letting us be on the steering committee and a sponsor for the group. These guys are awesome, and I love what you guys do and what you're about. So that wraps it up for me, Janelle.
All right. Thank you very much, Eric Chappell, everyone. Thank you for being our presenter today, and thanks to Autodesk for sponsoring our webinar. I hope everyone online enjoyed today's webinar and will also join us next Thursday for our next webinar on accessibility measurement made easy with Sugar Access by Robert Collier from City Labs. Until we meet virtually next week for our second webinar of 2017, have a very geospatial day. Goodbye.